Hello, welcome to our exciting calculus optimization problem dealing with airplanes. So we're going to take a look at another example here, setting something up a little bit different, more like you could say real life application instead of just finding areas of rectangles or something. So in our example here, we're going to say that in an airplane for a certain flight, an airplane ticket costs $200 if there's between 0 and 50 passengers on the plane. But as the plane gets fuller, they charge less. So for every passenger over 50, the price per ticket is reduced by $2 for all passengers. So for example, if there are 52 passengers on, 2 over 50, our ticket would cost $196 instead of $200. So what we want to figure out is how many passengers will produce our maximum revenue for this flight. What would be the ideal? So I want you to take maybe just a moment on your own, maybe pause quick and see if we can figure out what would be maybe our equation we'd be setting up here for this situation. Hopefully you've given it a try, at least tried to come up with something. So we're looking for how many passengers, that's our questions, like a variable would be passengers, I'll just call them X, because that's what we usually use. And what we're trying to find is our maximum revenue, that's our goal, so let's call that R. And I'm going to set up our revenue equation. When you talk about how much money do you make per selling something, it depends on two main factors. It depends on how much does whatever you're selling cost, what's the price, and then the other part depends on is how many you sell. So for our revenue is going to be the price of the ticket times however many people times our number of passengers. So how are we going to write that out? Our number of passengers is just X. That part's easy, but our price per ticket does vary. So if we're going to go on to a new one here. So if I'm looking at that price per ticket part, see if you can come up with how would you write that? That is $200, but when we have more than 50 people, it goes down by $2 per extra person. We're going to assume here as we're setting up our model that we are dealing with more than the 200 people. I mean, more than 50 people, excuse me. So our price per ticket is going to be $200. And then we're going to subtract 2 times however many over 50 we have. In that case, we'd have to take our number of passengers, X, minus 50. That would tell us how many more than 50 we have. So that would be our price per ticket. We got our equation here. Before we do our derivative and set it equal to 0, that's our eventual goal. As we usually do, we want to simplify this. That's sort of a mess there. That'd be a not overly fun derivative to do. So simplify that out. Take a derivative of it, set it equal to 0, see if you can solve it, and then we'll check back in, hopefully at the end. Distribute out that -2, and then I can distribute out the X, or I can combine some terms on the inside there and then distribute out the X. So we got a relatively easy one. Take a derivative of that. We're going to have 300 minus 4X, and we're setting that equal to 0. And that would give us then, when we solve that, 75 passengers would be our ideal amount of people to have on our plane here. So hopefully that made somewhat sense. Maybe watch it again if you need to, or check it out in the future. It's pretty exciting, I know. So good luck.